Welcome to the third installment in the PowerShell series. It's been a while since episode 2, but there's a pretty good reason. I've been fooling around with changing all of my devices to private, open, and responsible technology, and in the process I managed to lose my Windows VM. However, I'm now back up and running, so this series can continue. In episode 2, we covered objects, including properties and methods, the PowerShell pipeline, formatting and aliases, and operators. If you're new to PowerShell, be sure to check out the previous videos in this series to get started. In today's installment, we'll cover flow control, mostly focusing on loops and also functions. Okay, so here I am on my Windows 11 desktop. It's been upgraded since the last episode, but PowerShell should be pretty much the same. So I'm going to go ahead and open PowerShell here, and I'm actually going to make the font a bit bigger so you guys can see better. Okay, so that should be a bit better for you guys. So the first thing I'm going to show you is something we've done before, and it's basically where I'm going to get information about a module that I have installed, which is this Azure storage module. And as you can see, when I run this command, I get a list of all the commandlets that this module provides. Okay? Now, the thing is, if I want to get information for another module, I have to repeat the same command, but obviously give it the name of the next module. Now, it would be nice if I could do this for multiple modules at a time. And that's where the first type of loop we're going to look at, for each object, comes in. So I'll put in a list of my modules. So again, I'll say az.storage, and I'll also say SQL Server. And then I'm going to pipe. Now, to make this command easier to type, I'll press enter here. So I'm going to say for each object. So as you can see, this for each object here, okay, this is going to apply to this list that I gave it. Okay, this list is going to be piped into for each object. And I'll say for each object, get command module. And now I need to give it the object name, and that's where we can use this handy shortcut $_ Now you can also say PS item here, it means the same thing, but typically this is shorter and a bit more standardized in the industry. So we can do this, and as you can see, I get both the output of SQL Server, but also the output of az.storage in one output. So this command here has retrieved every object in my list and run this particular command on that object. Now, of course, the nice thing about a pipeline is that I can add as many other things as I want into my pipeline. So I've prepared the command here, which I'm gonna show you. So as you can see, this part of the command is the same, but then I'm also grouping the objects and sorting them. Okay, so I'll go ahead and run this. And as you can see now, they are grouped, and they're grouped by the module name property, and they are sorted by the count, which is this guy here, in descending order. So you can use a for each object command as part of a normal PowerShell pipeline, and this enables you to create pretty useful commands as I've shown you here. Now, this is only when you are iterating through a list of objects, but there's also another way to do it, which is to use a typical for each loop, which a programmer might be familiar with. So for example, I'm going to create this variable here called people, and in here I'm going to store two names, Keith and Harry, for example. And I'm going to say for each person in people, okay, and I'll say write output person. And as you can see, Keith and Harry are output to the console. So this is, I mean, obviously it's easier to understand and it looks more like a typical for each loop from any programming language. The difference is that when you use a for each loop, the items that you're looping to such as people in my case, need to be loaded in RAM all at once. Now in this case it's not a problem since I already have the variable here. But for each object, which we've done here, can actually load the objects that you've given one by one. So I guess this could be seen as a little bit more efficient as well. Now, of course, this is not the only way to do this particular task. For example, I could very easily have gotten my people variable and piped it into right output. And as you can see, I would get exactly the same output. So in many cases, this for each can actually be avoided, but I wanted to show you this example to show you what the for each does. Now, we can also use a traditional for loop here, just like you would in any programming language. So I can say for, and then I'll start at 1. So I'll say I equals 1. Obviously, the variable can be called whatever you want. And I'll say keep looping whilst I is less than 5. And at each iteration, add 1 to I plus plus. Okay? And then I'll say what I want to happen. So I'll say right output sleeping for I seconds, for example. And I'll actually do a sleep, start sleep. This is an interesting command. And I'll give I as the parameter. And as you can see, the loop is happening each time we are sleeping for 1 second. And then also we are getting output written to the screen. Okay, so that's a very traditional for loop. I haven't used this that much, but it is there, and so you can do this kind of stuff. Now we've seen the for each object loop, we've seen a for each loop, we've even seen a for loop, but PowerShell actually supports every type of loop. We have do while loops, etc., etc. Okay, so let's look at an example that I've prepared here. So this is a little number guessing game that makes use of a do until loop. So let's go ahead and look at how this works. So I'm going to generate a random number here. Now to do this, I can say number is equal to get random, and I'll say minimum 1 and maximum 10. And ideally spelt correctly. There we go. So now a number between 1 and 10 has been generated in number. Now let's look at this little script here. So as you can see, I have a do loop, and what I have here is that this loop, so this entire part here, is going to keep repeated until guess is equal to number. So until the user has managed to guess the random number. So as you can see, we're using the read host parameter to say what's your guess, and we'll say if it's less, too low, if it's greater, too high. This gives some tricks, and basically we'll keep repeating this until guess is equal to number, so until the user manages to guess. So when I run this, we'll get what's your guess. I'll start with a 5, and oh, it seems really. Yeah, it seems I actually managed to guess the first time here. Let's try something else. Okay, so 5, too high. Okay, 3, still too high. 2, too high. 1, okay. And I now managed to guess. Now, similar to the do until loop, we also have a do while loop. So here's that same exact program, but this time using a do while. As you can see, the program is pretty much the same. The difference is this part here. While the guess is not equal to the number, we're gonna keep repeating. Okay, but other than that, the code is pretty much identical. So I'll guess again, 3, too high, 1, and that was the number since I didn't change it. Okay, so you can see there that it does actually work pretty well. So we've seen the do until and the do while. Now, what about a traditional while loop? I hear you ask. Well, let's do one of those as well. So I'm going to say date equals get date. Let's see, February 5th. Okay, which is what today is. All right. And I'm going to say while the date, which is date, dot day of week is not equal to Thursday. It's Saturday today, so that's not gonna work. We'll say date equals date dot add days 1. Okay, and now if we do write output for date, you can see that it tells me 3rd of February, okay? Which does make sense because that's when 3rd of February was Thursday. Don't worry about the year here and the time, we weren't considering them. So basically this loop kept repeating until this condition here was satisfied, okay? So you can see that kind of stuff. Now, just like in many other programming languages, the break and continue keywords are also supported. So I'm actually gonna call up a program I wrote a little bit earlier, which was this one here, okay? So you remember that when we ran this program, it basically slept for 4 seconds, okay? Now what I'm gonna do is I'm going to load that little snippet of code again, but this time I'm gonna go up here and add a break. So you'll notice that now the program only slept for 1 second. So just like in many other programming languages, the break keyword causes a loop to terminate immediately. So basically we said sleeping for 1 second, and this is where it actually slept, and then we encountered the break, and so we immediately jumped out of the loop. Okay, so basically this causes the loop to terminate immediately. Now, you can't really talk about the break keyword without the continue keyword. So let's go ahead and do one of those. So I'm going to set 2 variables here, one called floors, which I'm going to set to 20, and one called current floor, which I'm going to set to 0. And I'm going to build a simple loop that simulates a lift or an elevator for my American friends going through the floors. So I'm going to say while the current floor is less than or equal to the floor count, which is floors, not flutes. I will say write output floor current floor, and then I will increment current floor by 1. And I've made a small mistake here because less than or equal to in PowerShell is LE, less than or equal to. So as you can see, this simple loop goes from floor 0 to floor 20. Now I've noticed that in the US there are quite a few places where the lift or the elevator doesn't stop at the 13th floor, maybe because of superstitious reasons. So what I'm gonna do is I'm gonna go back to my code and I'm gonna go up here and I'm going to add a clause. Now remember, when you're doing this, you can press Shift Enter to edit your command. And I'm going to say if the current floor is equal to 13, we will skip the current floor. So I'm going to say current floor plus plus and continue. Now strictly speaking, I don't really need the continue here, since the current floor being incremented by 1 would go to the 14th floor anyway. But work with me here, I'm just trying to show you how this works. So now I'll reset current floor to 0 and we'll run that code. So as you can see now, we go from floor 12 to floor 14. So once the break keyword causes you to skip out of a loop and stop it immediately, the continue keyword just makes you skip the current iteration of the loop. Okay, so we do 0 till 12, we get to 13, this if statement is true, and then we stop here, go to the next iteration, which is obviously the 14th floor. And then we keep going with this loop. So that's a pretty good overview of the looping capabilities of PowerShell. We've seen the while loop, do while, do until, for each object. You can see that PowerShell is pretty flexible in providing us with looping structures. Okay, so now let's talk a little bit about functions. So PowerShell, just like any other decent command interpreter, lets you create your own functions. Now, there is kind of a syntax that you should use which is verb dash prefix and then some sort of noun. So this is the recommended way, okay, of getting of creating PowerShell functions. Now, of course, this is not going to work. This is just for me to show you what it can be. Now, the verb part needs to be something that is approved or typically used in PowerShell, like get, for example. You can get a list of verbs by using getVerb. And I'm actually going to sort this list by using sort object. And I'm going to sort by verb, for example. So these are all the verbs you can use. Now, of course, to be fair, you can call the function whatever the hell you want, but it does make sense to use one of these since it makes your commandlet, act like a standard PowerShell function. So with that in mind, let's go ahead and create our first function. So I'm going to say function get-version. Okay, so as you can see, the verb dash and the prefix, in this case what I'm getting, which is the version, okay? And I'll just say ps version table dot ps version, and I'll close my function. Okay, so now my function has been created, and I can call it by saying get dash version. And as you can see, my function has run, and you can see I'm getting the output. Now, there's nothing wrong with this function here. The problem is that if you just use verb and prefix, there's a pretty good chance that something you're writing is already using that name in PowerShell. So what you can do is add some sort of mnemonic in front of the prefix, so that you can avoid conflicts. So we have the verb, which is get, we have a dash, then we have a prefix, which in my case is ps, and then we have the noun, which is version. Okay, so here we just have the verb and the noun. Here we have added this prefix. Now you can call it ps, you can put your initials there, okay, so I can say kv, version, whatever. That kind of reduces the chance that you're going to have a naming collision. And so now, running the function, you can see that it works exactly the same. Of course, it's the same code, it just has a different name. Now, once you've started creating functions, you can do something like get child item path function, and this will list all functions, so let's filter it. We can say get dash anything and then version. And as you can see, the two versions that I've created are here, get version and get kv version. And what I'm going to do is remove these functions. So I'll use the previous command and pipe it into remove item. And so now running the previous command again, you can see that those functions have now been removed. So, pretty simple stuff, right? Now what I'm going to do next is I'm going to create a function that takes parameters. So let's do a very simple one. We're going to say function test parameter. And I'm going to say there's a parameter in this function, which is computer name. And then I'm going to say write output, ideally spelled correctly, computer name, and we'll close our function. And so basically this function takes one parameter, which we're calling computer name, and simply outputs it to the screen. So now I can try it out, okay? Now you might be wondering, wait a second, how am I going to actually pass this parameter here, okay? Well, that's where the get commandlet comes in handy. So for example, I can say get command dash name and the name of my function, test parameter, okay? And I'll say, give me the syntax. And as you can see, it's saying test parameter, computer name, okay? Now you will notice that my parameter is inside square brackets. So that is showing me that the parameter is actually optional, which it is because I didn't put anything in here to say that this parameter is required. Now don't worry, I'm going to show you how to do that in a few seconds. By the way, we can also get this command here and put it in brackets or parentheses if we want to be exact, and then say .parameters.keys. And this basically just gives us a dumb list of the parameter names that the function accepts. Anyway, so let's try out my function. Test parameter computer name, and I'll give it the name of my host machine here, which is Oryx. And as you can see, the function works and it outputs Oryx off the screen. Now, what this means, guys, is that when you create your parameters, even internally in your function, you should give them a name that makes sense, since these names are what the user will have to type when calling the function. Okay, so this is not something like Java, where you can give your parameters whatever the hell names you want, because the user doesn't really see them. In fact, I actually chose computer name because it's a pretty standard parameter in PowerShell. Let me show you this piece of code. Okay, so I have this function called getParameterCount, okay? And it's basically going to get a list of parameters and the built-in functions within PowerShell. And as you can see, as a parameter, it takes parameter name. So I'm going to say get parameter count, and I'm going to say parameter name computer name. And as you can see, what this is telling me is that there are 23 commandlets built into PowerShell that use the parameter computer name. Now, what if I had called my parameter something else? Something like, I don't know, system name. You know, nothing, zero. So would it still have worked with this parameter name? Of course. But anyone who's familiar with PowerShell already would probably expect your parameter to be called computer name, since there are another 23 commandlets that use it. So as you can see, the naming of commandlets in PowerShell is perhaps more important than you are familiar with in a traditional programming language. The function needs to have a particular name type, as I mentioned, with the verb, dash, prefix, and noun. And the parameter names need to be sensical, but also need to be standards compliant with PowerShell, at least if you want to write professional-looking commandlets. Now, we are going to actually create another version of this function. So this guy here, okay? And what I'm going to do is I'm going to change its name so I don't overwrite the previous one. So I'm going to call it test commandlet binding. And what I'm going to do down here is above the list of parameters, I'm going to say commandlet binding. And what this does is it turns this function, which essentially does the same thing as the one before it, into an advanced function. Okay, so let me show you what that means. If I do get command name test parameter dot parameters dot keys, you can see that my previous function only took the computer name parameter. But now let's try this new one. So this is called test commandlet binding. And as you can see, just by adding this line here to my function, I still have computer name, of course, but I have all of this stuff. Okay, so this basically means that your function can now have verbose mode enabled. You can use it for debugging, you can assign an error action, and all this stuff. Now, how you actually assign all of these is something we'll be covering later in this series. But since we're covering parameters, it's good for you to know what this means, especially if you see it in ready-made code. Now, sticking to parameters for a bit, let's look at some parameter validation. So I'm going to again bring up a version of my code. And what I'm going to do is, in front of the parameter name, I'm going to add string in square brackets. This means that the computer name parameter must now be a string. Okay, now what I'm going to do as well is I'm going to rename the function so I don't overwrite my previous one. So I'm going to call this test parameter validation. Okie dokie, so there we go. So now I'm going to try it out. Test parameter validation dash computer name Oryx. So yeah, you can see that that works. And now I'll try a number, and as you can see, that works as well. So obviously some automatic conversion is happening here from new number to string. Okay, I can even pass it in quotes. Yep, and that works just fine as well. So no real effect in this case. But what if I created version 2 of this function? I'll call it test parameter validation 2. And this time, rather than string, I will say int. And now I'm going to say test parameter validation 2 dash computer name Oryx. And as you can see now, we get an error. It says cannot process argument transformation. We cannot convert Oryx into a number. Now, if I pass a number to this function, that's just fine. Okay, so as you can see, the parameter types here are actually strict types. Okay, they're not dynamic types, or type hints, as with many programming languages like PHP, for example. This is a strict type that whoever is using your commandlet, or in this case your function, must follow. Okay, now if I wanted my function, I'll go back to this version here. Yep, if I wanted my function to accept multiple strings, not just one, I can put square brackets there to say that I accept a string array. And so now when I run my function, I can say computer name Oryx space Oryx, comma, Athena, and as you can see, this write output command will accept multiple computer names, in this case, for it to work. You will notice I made a mistake myself here, that you must use a comma to denote that this is a list. You cannot use a space. So as you can see, pretty flexible with this thing. Now, what happens if I run my function again, but this time without any parameter whatsoever? As you can see, nothing happens, which is to be expected. But then again, shouldn't we get some sort of error that that parameter is mandatory? Okay, well, we're gonna do just that. So going back to this function, I'm gonna go here, Shift Enter, and I'm going to add here parameter mandatory. So by adding that, I have now made my parameter mandatory. So if I try to run that same function again, you can see that it says test parameter validation, supply values for the following parameters. Interestingly, it doesn't error out. It actually lets me add the parameter here. So I'll say, okay, Oryx then, and another one, Athena, and that's it. And obviously in this case it closes. But if I go and change this so it's no longer an array, and I'll try it again. Yep, as you can see, now it works. So it's pretty interesting. Even if the user forgets to fill in the parameter, PowerShell doesn't just quit on them. It instead simply asks them for the values of the parameters that they want, which I think is pretty cool. Now, since we have mandatory parameters, do we also have optional parameters? And the answer is yes. So I'm going to go back to my function here, and this time, rather than parameter mandatory, I'm going to say validate not null or empty. And then down here, I'm going to say computer name, and I'm going to give it a default value. So what this means is that if a computer name is given, then that will be the value for this parameter. But if one is not, then this will be the value of the computer name variable. Note that you cannot do this, meaning set a default value, if you set the parameter to mandatory, because it will still, mandatory still means the user must give us a value. So when you want an optional parameter, you add an equal symbol here, and then to make sure it's, not null or empty, we add this validate not null or empty specifier here. So now I'm going to try this function out. So test parameter validation. I'll try it first with a proper one. So computer name Oryx, and that works. And now I'm going to try it again, but without the parameter. And as you can see now, the computer name is the default value, which is, in my case, is the computer name variable from the environment, which is key to Win11 VM. So that's how you can create optional parameters in your functions. Now let's modify our function a bit. So what I'm going to do is I'm going to make this an array, so we can have multiple computers, and I'm going to combine into this function what we've just covered in the previous topic. Okay, so I'm going to go here, and I'm going to say for each computer in computer name, and then I'll put this one here, close the loop, and close the function. And so now I should be able to run this function, give it to computers. Oh, and I'll also need to change this to just computer now. Okay, so I'm going to try it with 2 computers, and as you can see, that works just fine. So basically my function is now looping through the list of strings we give it and writing output as necessary. One thing which we typically add to our commandlets or our functions, especially if they are advanced functions, which is what we have with this guy here, the hash is not required, by the way, that's just a typo, is verbose output. Okay, so let me show you how that works. So I'm going to go back to my function, and before we write the computer name, I'm going to say write verbose message about to do something with computer, something like that, whatever, doesn't really matter. So now if I run the function normally, you'll see that it runs just like before, but I can now add the verbose option. And as you can see, it's saying about to do something with Oryx, about to do something with Athena. So just by using this write verbose commandlet, your user can simply add the verbose option and voila, verbose output for when they want to debug or see what's going on here. Now, another thing you might want to do with your functions is allow them to receive parameters via the pipeline, via the command pipeline. So that's what I'm going to show you now. So I have a function here called test pipeline input, and as you can see, it has the advanced mode enabled, and I have a parameter which is mandatory, which is value from pipeline. So as you can see, I'm telling PowerShell that this parameter should be coming from a pipeline, and that it's a list of strings, which I'm going to call computer name, and all I'm going to do is actually write out the output. Now you'll notice here that there is this process section. This is optional to add in a function, but kind of recommended. This is kind of like the begin and end of a function. So whilst this is the parameter list, this is the processing the function carried out. Optional, but recommended. So now obviously if I try and run this function on its own, you'll see that I need to supply arguments. So the way to run this is to provide my parameters, for example, Oryx and Athena, and pass it to the test pipeline input function. And as you can see, it works just fine. Okay, so the value of the computer name parameter is now coming from the pipeline. So you can see how powerful this is, as you can create your own functions that process a pipeline. They take input, they do something with it, and if I add another pipeline here, that output can then be used by some other commandlet. Now the last thing I want to show you is error handling. Okay, so I'm going to go back to this function here. So far, computer name has just been a string. But what if they were actually computer names and we wanted to do something with them? So I want to see whether this is an actual computer name that's been passed or just a string with some text, which is what we've been doing so far. So what I'm going to do is I'm going to rename this function to test. Let's see, let's give it a proper name here, KV error handling. And then what I'm going to say is that it's mandatory, the value comes from a pipeline, and I'm going to add another one here, which is value from pipeline by property name. Okay, this remains the same process. Now what we're going to do is we're going to add a loop here for each computer in computer name. And what I want to do is I'm going to run the test wsman command, which actually does require a proper computer name to run. Okay, so we can actually remove this guy here and just add the closing brace for the for each. Yeah, so we're going to give a computer name and then we're going to test whether this is an actual computer name or just a string. Okay, so now we'll test it. And as you can see, what's happening here is that we have an error and it's saying the WinRM client cannot process the request because the server name cannot be resolved, which obviously makes sense because Oryx isn't an actual Windows computer running on my network. Now, it makes sense that we got this error, but the error is really ugly. You know, it would be nice if we could actually handle this error, so at the very least we get a decent error message. So that's what we're going to do. So I'm going to load up my function again, and I'm going to identify which line can cause errors, which in my case is this one. And what I'm going to do is before that line, I'm going to add a try. So that basically means try to do the following command. If it runs fine, then that's no problem. However, if something goes wrong, meaning an exception is raised, catch it. So we'll say catch. And I'm just going to prepare the curly bracket here because it's getting a bit complex. There we go. And in case there's an error, rather than letting the default happen, which is this huge error here, I'm going to write a warning myself. Write warning, message, something like unable to connect to computer. So this means that we should get our own error message. And I'm going to try it out again. Interesting. This didn't work. As you can see, we still got the same error message. Now, the reason it didn't work was because if we go back to the function, the error that this function was encountering is still being sent to the console before PowerShell has time to catch the error in our own function. So what we need to do is we need to go here to the command that we're running, and we will add -error action stop. So this tells this commandlet, yo, if you have an error, just stop, don't do anything. So now let's try our command again. Aha! And this time it says warning, unable to connect to computer Oryx, which is much more presentable. So as you can see here, by using the correct error actions and using this try-catch syntax, we can easily catch errors. Try to do what's in this part here. If there's an exception, do what's in this part here. And that concludes today's installment. So that's it for today's episode. Loops are a really important concept since processing things in batch is something we do a lot on the command line. And obviously functions are very important too, since they can group together things that we do often, and they become essential once we start scripting, which we're gonna do very soon in this series. I hope you found this video informative and that you've learned something. If there's anything in particular you want me to cover or something you think I've missed out, please let me know down in the comments below. And whilst you're browsing there, please give Tech Guru a like and a subscribe, as it helps a lot. Also, if you want to support me on Patreon, like the brilliant people on screen now, please consider doing so. You can get early access to videos, a private chat room, technical support, which is particularly useful for this topic, and many, many more things. Oh, and I'm also on Odyssey if you want to catch these videos without using YouTube. Thank you very much for watching today's video, and I'll catch you next time.